And we're back with some more Factorio. And I have no idea what's going on anymore. Yeah, it's been a few months, so this might take a minute to get back up to speed. I believe we were on the trash planet. Sorry, the recycle planet. You know, it's the trash planet. And we were trying to set up, yes, science, so that we could output it off the planet. Though we had not figured out... Actually, wait a minute. You know what, I got an idea. So, according to the last video, we built this whole thing, and then we were about to look for bottlenecks, but we ran out of time. So basically, we have to figure out the bottlenecks in a system we don't remember designing from several months ago. Yeah, this is going to be fun. I'm sure this is going to break horrifically. I just won't know because I'm not sure what I'm supposed to be looking out for because I can't remember designing the system. Like, that looks pretty dangerous. How are you guys doing? No, they're actually staying on top of things. Ice here kept backing up, so we stuck in a ice recycler, but I'm pretty sure that's going to back up too. We're going to have to come up with a system to recycle things a little bit better. Yeah. You know what? The hell is this? Entities are being damaged. No. I remember this. We have, like, lots and lots of repair packs, lots and lots of stuff. This planet should be pretty safe to not worry about. Where were we? Oh, yeah. Trash Island. Damn it. Okay. I figured out what we got to do, or the chore that was left to us by past Francis, that asshat. Simplest thing to explain first is probably power. Right, this whole place is just powered by lightning strikes at night. It's like reverse solar. And these capacitors get charged up during the night, and then they run the factory during the day. However, we stuck in some of these steam turbines, and they're powered by some heat exchangers, which are powered by heating towers, which are powered by rocket fuel, which is made from solid fuel. Not a big deal, but the most important bit is ice. The only way to get water on this planet is to break down this recycling material, and occasionally it spits out little bits of ice. And that ice we convert to water. And that water we have to feed into the steam turbines to make steam. Or, well, sorry, the heat exchangers to make steam. But we need to make sure we have enough ice to run our main industry, which is, well, producing all this science-y stuff. So over here is the main water production for that. All the ice that gets produced eventually filters to the end of the line and gets chucked into this chest. And then it gets put into this machine. This is the vitally important one. This one churns out the water that gets dumped into this tank, and that provides the water to run the splitting facility to make light oil. Or at the same time, it provides the water to make the holmium solution that we use to make plates that go into making the actual science over there. So this is vitally important. So what happens here is this gets filled up to about here. If it goes over this point, this activates and dumps the excess ice out here, which can then get turned into powery stuff. Grand so. However, we're going to produce more ice than all of those other things can consume. So what happens is the excess ice basically overflows onto this line. Come on, give me some of that. Oh, there we go. And once it overflows, it gets put into the recycler. And then 75% of it is destroyed by the recycling machine, and then a little bit of ice comes out. So basically, for every 4 that comes in, 1 ice that comes out, and it just keeps rotating around, making sure that this line never backs up. However, problems. We have no consumers of concrete. We have no consumers of steel. We have no consumers of low-density structure. So we gotta basically destroy all of those, or basically just put them onto a belt going around in a circle where recyclers just eat them and spit them out and eat them and spit them out until there's nothing left. Then again, there's some other problems we face. Let's see, how about you? Oh god. We actually might be producing too much of this holmium ore, so we might have to find a way to dispose of that. We might be producing too much copper ore. The iron gears... Oh no, we fixed those already. Yeah, I believe the iron gears all get fed into this machine. And then they get, any excess get turned into chests. And then the chests get trucked back into the recycler to make more iron plates. Yeah, so all we have to do is come up with some way of disposing of these 3 items first. Then make sure we don't overload on solid fuel, don't overload on gears. Battery-wise, we're actually eating through the batteries at an alarming rate. You know what, it's probably fine. Probably? Yeah. Oh, and we're producing an excess of accumulators. Those excess of accumulators we then deploy to provide us with more power. I mean, we have a gargantuan amount of power around this place right now, but I'm not sure how long those accumulators last. We might... Oh, 1 second. We might need... Yeah, we're going to need more of them. Once we start putting in speed beacons and productivity modules into these things, it's going to get real power hungry around here real fast. But first, let me figure out how we're going to get rid of these 3 items. So, yeah, it turns out low-density structure is really painful to destroy. It turns into a lot of steel plate, copper, and plastic. This is insane. We're going to have to come up with a more efficient method. But for now, I want to try some brute force just to see how ridiculous this can get. So basically, we're just taking all of the excess low-density structure, we're chucking it around here, and then trying to destroy it by feeding it right back into itself. Not very good. It's not amazing here. How are you doing? Oh God. Why are you not feeding anything in? Oh, you're looking for copper plate? Why do you want copper plate? Take anything. Here you go. Oh, you can't output it, can you? Well then, this is awkward. Yeah, there's a more efficient way to do this, but I'm pot committed now and I'm not stopping. This will eventually work, right? Right? Okay, so I think the initial problem was we fed too much into the system too quickly. We've basically taken a huge backlog and chucked it on. So now we've chucked on quite a bit of extra low-density structure. And now we're going to see what that does to the system. Then what we can start doing is adding in the steel and the concrete. How's the fuel doing? We're also going to need to start adding in fuel as well. Yeah, the fuel is maybe getting a little bit overloaded. How's everything else looking? No, everything else is doing fine-ish. Yeah, so we'll just dump some of that stuff into a machine and get rid of it. Okay. Time to dump steel onto it. We've managed to catch up with the backlog of low-density structure. And we've chucked steel on here, and we're going to use, well, steel chests if this becomes a problem. So the steel goes along here, it gets picked up by the recyclers, immediately dumped into another recycler. So this will reduce it by a quarter, and that will reduce it by, well, another 3/4. Or this will reduce it by 3/4, and that will reduce that quarter by another 3/4. So we're going to end up with a lot less steel coming out the other side. And any that makes it all the way around to the end will get picked up by this and turned into steel chests, which should hopefully make it a little bit easier to deal with. Anyone want to grab that steel chest that's just sitting there? Steel chest, just floating about, people. Anyone want it? Anyone? Oh my God, no one wants it. Oh, and this end one, this is just for, well, personal stuff. When you want to get rid of something, you chuck it on there. Oh, that's the plan. So far, that seems to be keeping up with steel. You know what? We have a bunch of steel we need to get rid of at the moment, so we're just going to chuck a bunch on here. Yeah, let us keep a few stacks. And that should hopefully keep up. We want to make sure that this thing can't get overloaded, because once we start piling efficiencies on this, turns out there is scrap recycling productivity. Gets up like a 10% bonus. I don't know if that works on the actual scrap itself or on the subcomponents. So like, do we get 10%? Like if we put in steel into a recycler after the bonus, do we still get 10% more steel back out? I mean, it would never go above the 100% mark, I assume, to stop us infinitely creating resources. Maybe it only works on the actual scrap itself to keep things fair. And why is that backed up? Something's backed up here, and I don't know why. Which line? What? No, you're good. You're good. I don't know what caused that. What the hell is going on here? I didn't even do anything. Stone. It's the stone. Okay, okay, my bad. We need to empty a bunch of this stone out. Well, the plan was to figure out what was going to gum up the works. You can go there. Rest of that stone can get dumped. Wow. That steel takes forever to process. And it has immediately gummed up the works. Oh yeah, no more steel. We need to... Oh man. I don't think this system can handle it. We may have made a mistake here. It's okay. It's okay. Alright, I think we found a solution. Lots of steel chest production. We basically whip the steel off the line, turn it into steel chests, then that gets dumped into these and it recycles really quickly. The problem was the actual steel itself recycles very, very slowly. Whereas we can take, what is it, 8 steel plates, dump them into this, and they vanish instantly. The steel chests are much faster to recycle than the actual steel plate itself. So that basically frees up the line, which means we can, you know what, let's put on more. How's the concrete looking? Yeah, we're going to have to deal with concrete in a second. I am not looking forward to that. Alright, seems to be working. How are we looking on the dirt front? You know what? Let's... I think putting dirt onto the line raw should be fine. It processes at enough speed. It should make no difference. Like that just... It went through that stuff at speed. That was perfect. Alright. Steel-wise... Wow, this is actually really good. Like, most of it's not making it past. We're getting a little bit of steel recycling going on over here, but most of it doesn't seem to get past this point. It just gets eaten so quickly. This is way faster and more efficient. Okay. Like, look at that stuff. There's a massive trail of it coming down, and it's instantly gone. How are you looking? Ooh, should we put on a third? Nah. I was going to put on a third inserter, but I think we're good enough. If it can handle that for now and eat all of that spare steel, we should be good. We've also made sure to set up a little bit of automation here to keep a stockpile of these, just so we can keep enough around for us to, well, use. Alright, we've caught up with the steel. The steel is now being eaten, the low-density structure is now being eaten, and now we've got to stick on concrete. I can't figure out a way to minimize the concrete, and it seems to be a slow one. It takes a while to eat this stuff. So this backlog could be a problem. Also, how's our dirt doing? Ugh, our stone. Right. Yeah, stone's a bit of a problem as well. We might want to come up with some sort of little system here that's self-contained. Like, that might not be too much of a problem. Like, we could just put in a little stone system that triggers if this chest is full, let's say. And assuming this chest is full, then we activate something to start draining off this end of the line. So, this actually turned out to be a lot easier than I thought. Instead of integrating it into our little... Oh my god. What happened? Refined concrete is what happened. Well, we'll maybe cut that off for just a little bit. Oh, sorry, the concrete's just a little bit too much for the system. Oof. A little bit way too much for the system. Gonna have to start taking some of this out, I think. The refined concrete might be the best thing to... Or the concrete might be the best thing to remove, though. Can't really prioritize. We just need to get the system moving again. Because right now a bunch of the outputs are blocked. Fine, we're going to fill up our inventory full of junk. But we'll get rid of it later. Alright, kind of working. Again. Hey, over here. Very simple. We've got a little bit of automation set up to this chest. If this goes above, I want to say 1,000? Yeah, 1,000 stone. This activates this inserter. This inserter takes stone off the line, dumps it into this. Then we block the outputs with pipes. And they even need to. We could have just let it fill up the ground. But then basically just bounces it back and forth between these two. The output of this gets sent into this, which then gets sent back into it. And it just keeps rotating around. It seems to be able to keep up with everything just fine. And how are you guys doing? Let's see, back up and running again. No problems. Yeah, we're going to need to have some way to stop this from overflowing, because the overflow is the big issue. Maybe we should just dump this concrete in a different way. Yeah, find some way to dispose of this concrete that doesn't interfere with our main little system over here. For this, we're just going to use the same setup we used on the stone. Basically just two recyclers feeding into each other. Seems to be pretty fast. If there's more than 2,000 solid fuel in here, it activates this inserter, which junks it in here, which tells it to rotate around into this thing. And done. Actually, I'm doing this wrong. Damn it. How about... Yeah, better. So this way it'll output this end and onto the fuel line. Because right now, I don't think any of the fuel's making it to the end of the line. We have a little bit too much fuel coming out, do we? 2.2k. So until it catches up, we're actually running behind on fuel. Give it a second. What are you at? We're at 2.1k. Fix the problem. Put in a bulk inserter over here. Now it can put in more fuel down the line than this thing can handle. So we shouldn't have any more problems. Yeah. Done. Okay, so we have sorted out solid fuel, concrete, steel, low density structure. We haven't done blue chips yet, though we have done ice. We've also sorted out stone. Still leaves a whole bunch of other things where we have to take care of all the excess overflow, and it's starting to get really spaghetti looking around here. Okay. It's pretty mild, I'd say. This is not that bad. This is a bit of a dirty way of getting rid of lots of concrete, but that should hopefully get rid of our backlog. Over here, our little recycling system is definitely handling the excess, though we haven't plugged in the blue circuits yet. But so far, it's kind of running. Now, over here, how are we looking on... Yeah, we're still backlogging accumulators, and we've got enough science to do our first load back to base. I think the system kind of works. Still not finished, though. We have a few more things we still need to fix. Basically, blue circuits to make sure they don't back up. Oh, not sure about the rest of this stuff. Are they... I think copper's broken, is it? Damn it, what's going on here? You know what? We're going to just have to let it go full bore. We'll have to figure out where the problems are. Run it until it breaks. To speed things along, we've productivity moduled these. We've only got productivity modules level 2 at the moment, but that's fine. Speed modules level 2 and some speed beacons. That should drastically increase productivity and put a massive more strain on the system. Let's start to see where this thing breaks down. I'm curious. Also, we may need to find a way to dispose of all this excess copper. Could be a problem. Well, we're starting to get a backup on this. Oh my god. This just looks worse and worse the more... Alright. It's fine. It's fine. It's not... No, ice is good. Stop looking at other things. Just concentrate on this. Okay. So, we have this copper cable that comes off the line. We get raw copper cable out of the recycling. But also, we recycle the red chips so that we can get green circuits out of them so that we can use them for production. But this also gives us more copper cable. And that feeds into here so that we can turn it into copper plate. We need the copper plate to actually make this stuff over here. The, what the hell's this stuff called? Superconductors. Yes. So, the problem is we were producing far too much copper cable and it was backing up the system. So all we've done now is this copper cable that we turn into copper plate. We actually have a little recycler here that rips copper plate off this line and feeds it back into this machine just to make sure that we don't backlog too much. So if there's too much copper cable in here, this machine activates and destroys copper plate. Yeah, that's what we're reduced to. And I don't think we're getting enough green circuits anymore. Once we started overclocking things, yeah, the whole system started to have problems. I'm not sure we're getting enough, whatchamacallit, batteries. Yeah, I don't think the batteries are making it all the way to the end of the line. I think we need more of them so that we can make superconductors. We might actually have to start making batteries. Oh god. Please, no. Wait, can we? Can we even make batteries in this setup? I don't think we can get sulfuric acid around here. Huh. The batteries are the main limiting factor? Might be, actually. Does that mean we set up a whole other line of recycling just to get batteries and dump everything else that's not batteries? That might be a fun challenge, but maybe not just yet. I think we're still going to have to work on a few other bottlenecks. One is holmium ore, whatever. It's fine. Can we actually chuck that into a recycler? I'm not even sure we can. You know what? Let's try that on our test recycler down here. Can you take this? Yeah. Yeah, you can. All right, perfect. That means we can just stick on something on the end of that to kill it off. I think that's almost everything. Okay, the red circuits won't back up. What the hell? Why are you... Something's going wrong here. Plastic is backed up. Yeah, the plastic backed up in the system. That's a problem. Yeah, we need to make sure that we fix the plastic back up. Damn it! There's always something. Where do we chuck the destroyer of plastics, I wonder? Never mind, we got bigger problems. I don't know what happened. What did we do? Oh, blue circuits. Blue circuits introduced far too much. So, 1 second. I think I know what we can do to fix this. Might take a minute. Well, the problem has become very clear. Basically, blue chips, they just saturate the belt too much. It's just they're made of too much gunk, and you end up with, well, a lot of green, a lot of red, a lot of copper cables. It's too messy. So we need to come up with a way of disposing of just a huge quantity of blue chip processing units. I've never had a problem in this game where I had too many blue chips. That's, this is a nice problem to have in a way. Oh, and I still gotta fix that plastic at some point. Yeah, in a minute. To get rid of the blue circuits, we've tried a slightly different tack. We might as well learn some stuff already. And basically, we just moved it way out of town. We moved it all the way over here. And then I thought, well, okay, we chuck the blue ones in here, and when we do, we get a green and red circuits. So we'll just split those onto 2 separate sections. So the reds go down here, and the reds, when you break them up, they only spit out green circuits, plastic, and green circuits. So the great thing about the copper stuff is we just chuck it into these, and then they just spit them back and forth. So that's it. This copper cable comes in here, and then once the copper cable spits them out, it goes into here as copper plate. The copper plate gets spit back across, and boom. It just keeps going back and forth, and they keep destroying each other. Same with the plastic. Green circuits come down here, get split into 2 parts, and then spread out again. And that's it. So they're like, just take stuff, split it up, and then until eventually you just get down to one singular component. Now, it's not perfect. You end up with a lot of green circuits, like a lot. So you've ended up having to stretch this a little bit and stretch things on just a tad. But say right here now we've got too much copper on the line. So that's a little bit too much copper. So what we'll do is we will just say you. Right, 1 second. Put you there. And boom. Now we have something else destroying all the copper, and that will quickly take care of the problem. Now all we have to do is make sure it's decreasing the amount of blue circuits. Now we just filled this up a while ago, and yeah, it's definitely keeping up with all of the blue circuits being produced, which is good, because that's an enormous investment of infrastructure. God, I hate and love this planet at the same time. It's definitely frying my noodle. Alright, how are we looking on batteries? Batteries have finally backed up. I think what we need to do... what we want to do is spend the batteries when they're there, so that we can make more accumulators to expand out our power grid. But to do that, we need to measure the batteries here. You see, the batteries are used in 2 things. They're also used down here to make supercapacitors, which then go on to make science. So what we have to do is put, say, a check, say, about here, to make sure there's 4 batteries on the line. And so long as there's 4 batteries here, that means there's a backlog. As long as there's a backlog... yeah, that should work. We just need to give ourselves a... you can go... there's fine. Why can't you... damn it. Alright, well, we'll need it to get ourselves together a little power pole. Okay, so this thing is set to detect if there is 4 batteries on this red line over here, which is connected to this chunk of the belt. So if there's 4 batteries here, then this thing starts operating. And there they go. Oh, damn it. That might be too much. Actually, no. It's fine-ish. How are you looking? Yeah, we want to burn through those. We need to fix the plastic as well. But we're finally getting through most of the bottlenecks. That was the plan, and it's kind of working-ish. Oh, damn it. Just look over here. This thing is getting... there's more green than there should be. I don't think we're keeping up with it. Actually, no. One made it around... like, I don't think we're getting a backlog. Still, the odd one creeping through... yeah, I don't like that. We'll put down another one here just to be absolutely positively safe. And then all we do is we just extend this sucker on a little bit. Done. And that should make sure no more greens escape. We might have to put in some more copper down here, but it seems to be fine. We'll keep an eyeball on it. We might have to upgrade things a little bit here and there. At the moment, though, we're just cutting through the backlog of blue circuits. Which, yeah, there's a lot. Those things take a lot of resources. Okay. Minor issue with the, not with this one's fine for now, the green circuits. So we were not making enough green circuits to keep up with supercapacitor production. Yeah, so what we did was, all of those blue chips were trashing. We siphoned off all of the green circuits. Well, yeah, I know. It's sushi sanity, I swear. But all the green circuits get sent up here. One second, we'll have to go this way. Cliffs. And they get sent back around and fed into them. So this way we keep the supercapacitors going, but it prioritizes income from this direction, which makes sure that the green circuits won't back up here. And done. That's given us a bunch of science. Great. Well, that actually makes sure that the supercapacitors back up. We might want to put in some more speed module things here. Yeah, we can put in one there. Yeah, it's super tricky to get in another one, but I think that will be fine. That will... yeah, they should produce them. Yeah, look, they're already backed up. Perfect, perfect. Now, battery-wise, I need to make some changes. I set this up so that it would only take these capacitors if... or sorry, the accumulators, if we had enough batteries coming in. Problem is, it would then drain the entire line and none of the accumulators would make it to the end of the line, which was a bit of a problem. So I need to change that somehow. To deal with the plastic, which I put on the long finger for far too long, all we've done is we've just hooked up a a quick automation wire. If there's more than 4,000 plastic in this case, it picks up the plastic, dumps it into this spits it across into this, and then that just spits it right back over, and it just, boom, eradicates itself. Great thing about plastic is it doesn't break down into component parts. It just spits out a quarter of the plastic you put in. And that should take care of that, which has been nagging at me for a while. I just have been very lazy about getting around to it. I think that's that done. Yeah. Now, problems. I don't think... Do these guys need green circuits? No. So green circuits are coming from... You know what? Doesn't make a difference. All this is still flowing as normal. The batteries have become the bottleneck again, which means I think we've turned off the accumulators for now. We might want to set up a little mini factory to produce nothing but accumulators. And I have to actually keep an eye on these. One of these days, I'm going to actually have to keep an eye on the accumulators and make sure that during the entire day time period, these things don't dip out. As in, I want to see just how much power we're using in a single day. Been doing a quick check here on how the accumulators are holding up during the day, and the answer would be really, really well. I'm not sure exactly what's happening here. Maybe we just have so much it makes no difference? Or maybe there's the odd lightning strike during the day. Okay. Just to the last minute. Okay, I'm not seeing any charge coming from the lightning rods, but there definitely is. The steam turbines are keeping a little bit of baseload power going. And we're not even... Alright, let's just fast forward a bit and see when nighttime kicks back around again. How much power we got in the tank. Alright, this is weird. Power's actually going up instead of... I think there's still the odd lightning strike that happens. Yep. Like, there's still the odd one that goes on. So I think it just never really stops. And once you get large enough, you're always... Damn it. What entities were destroyed? 2 entities destroyed. 10 entities are being damaged. They get some of the construction robots again. Damn it. There's only 3 construction robots left, is there? No, there's 53 construction robots on that. We're good. We're good on the construction robot front. Yeah, nope. I think I was smart enough to not mess up on that front and make sure that was well maintained so we never had to go back for a while. Yeah, I'm gonna have to figure out what all these other places are doing as well. This one can wait, though. I'm pretty sure that so long as this keeps doing whatever it's supposed to be doing, I think we can ignore this one. Yeah. Bulgora, on the other hand, yeah, we have encountered a bottleneck. One that is annoying me. Basically, batteries. The batteries we're getting are not enough. There's not enough batteries, and because there's not enough batteries, everything slows down. So the first thing I did was extended out this trash line, which didn't really help much. I mean, it's increased throughput by a bit, but these end things are just not... Like, nothing's going through there, you'll notice. There's barely any movement on any of that stuff. So, what I'm thinking is, we actually produce batteries. I mean, we've already gone to Spaghettiville. We might as well just, like, commit fully. Like, how are we looking on the liquid over here? So you're... okay. So, what we can do is we can take the light oil down here and split it. Crack it, split it, whatever. And turn it into petroleum. And then we can use that petroleum to make sulfur. And we can use the sulfur to make sulfuric acid, and then sulfuric acid combined with some copper and iron and we'll be good. And I was thinking for the copper and iron plate, we could probably pull it out of the system. Shouldn't be that hard. I mean, instead of just destroying the copper, we filter the copper off the line and send it over to where it needs to go. And then any leftover copper or any excess copper we just plug back into the system. Should be grand. And here is the results of the start of that plan. We're going to take the water we're pumping down here from this setup, and we're going to feed it into this splitter, light oil cracking. So we're going to take the medium oil, the light oil, and turn it into petroleum. And then that petroleum we feed in here with water to give us sulfur. Now, batteries. Oh God, how are we going to do the batteries? It's been a while since we played, so we're going to need iron plate, copper plate, and sulfuric acid. Okay. Sulfuric acid-wise, we're going to need iron plate, sulfur, and water. Okay, so we're going to need iron plate, copper plate, water, and sulfuric acid. Easy peasy. Easy. I really wish we had more space. I think we're going to have to ship this sulfur somewhere with a little bit more room. Might be an idea, actually, to go over this direction. There's a little bit of a space here we might be able to set up. require some transport belt fooey, but let's face it, that's just par for the course at this point. Okay, this, yeah, it's an abomination. This whole thing is horrifyingly bad. The sulfur's coming from over here. It gets put in here, combined with some iron plate. We're sort of siphoning off this mess. Combined with some copper plate, we're siphoning off this mess to make, finally, the batteries. Now, I'm not even sure how much throughput we're going to get on this or how useful it is, but we did it. Now we just have to somehow figure out how to get those batteries from over there to over here. Probably the best way to thread them in would be in through, like, through here somewhere, or... Yeah, it's going to be nightmarish. Right now, we're going to make a whole bunch of transport belt, though. Hold on, why are we making iron gear wheels? We already have, like, a lot of iron gear wheels. We're good on the iron gear wheels front. Well, turns out this little garbage patch is starting to run out. We're going to have to start tapping into other patches of garbage. What was this for? I don't think it matters anymore. I'm afraid this garbage patch is about to become useful again. Yeah, there's not a lot here, though, is there? 503, 503. Well, more than we've got over those sections. So there's 503,000 garbage there. Oh, 37 million. We might need to set up a train station. You know what? This area first. Wait, no. Batteries first. Also, we probably want to queue up like a bajillion more transport belt. We're going to need it very shortly. So, yeah, give us all of these. We're going to need a bunch of you. Yeah, if you want to make transport belt, you need a lot of gears. Okay, let's plug in some batteries. A very small amount of batteries. I don't think this is going to be able to keep up very well. Also, we might want to start stockpiling some stuff. Actually, we can't. This is actually too close together. We might want to start putting speed modules or speed beacons in here, but we've used up all the ones we came with. All of our speed modules are gone. But I remember now, what we were trying to do is do all of this without bringing anything down from space. We just chucked in a few speed modules and productivity modules just to, like, so that we wouldn't have to redo the whole thing. But we didn't bring down any blue transport belt. Blue transport belt definitely would have helped over here for sure. But the reason we did all of that is we wanted to see if you could build this all up from scratch, which we've done. Which I think is pretty good. Yeah, and there is the batteries coming along now. Not a lot. Yeah, we definitely need a higher throughput on those. What are you missing the most of? Actually, they seem fine. It's just a speed issue. So, a little double down. And now we've got 2 little battery plants. Alright, it still will be unlikely to fill our requirements. Unless we maybe productivity. Actually, you can't even think you can productivity those. Probably speed module it. But it should pick up science production. You, give me over the last, say, hour what our science has been doing. Yeah. Not great. 57.7. We need about 100. This needs some more work, for sure. That little addition should handily keep our scrap up to speed. Yeah, there we go. Much better. That'll backfill it. Okay. So, batteries online, everything's starting to move through. Let's give this about 10 minutes and see how we're doing. Also, I've looked back through all my notes and then went and did a bunch of playing on calculators. There's like a lot of background stuff where you're just trying to figure out what you did and why it looks so dumb. This thing is just, so silly. But hey, so long as it works, that's all we care about at the end of the day. And if we mess up any of this, the fact that we're actually recycling most of this copper and iron to do something useful with is not bad. We could get rid of 2 of these, but I'm leaving some of these in here just in case something goes wrong. I figure we're definitely getting enough of each. If there's any overflow iron, goes in here. Any overflow copper goes in here and they get destroyed. The additional battery production that we set up down here has, of course, had a bunch of unintended side effects. Well, one unintended side effect that I'm aware of. That is ice. We have basically eaten through our backlog of ice because we need that ice to make the water, which is required for, well, for splitting or light oil cracking. It's also required for making the sulfur. It is also required for making the sulfuric acid, which means, yeah, it's eaten through a lot of it, but we're not actually producing enough sulfur to keep up with everything anyway, so it should now slow down and start backlogging a bit. Well, that excess ice was being used down here to make water, to get fed into steam turbines down here. So, yeah, there won't be that power anymore, but I'm not sure it'll make much of a difference. Considering how well the accumulators were holding out, though, I suppose we will find out soon enough. And when it comes to production, for the last 10 minutes, it's averaging about 70 science. It's not great. We were hoping for, I think, 90 when we originally started this, according to the video, but I was going to get about 100 out of it. Well, I know what we're going to do to fix that. It's called Blue Transport Belt. Makes things a lot easier. Thankfully, we have brought along the Event Horizon, and we can just jump down and say, ooh, give us like a couple of stacks of those blue belts, if you wouldn't mind, and some, yeah, some of those express splitters would also be excellent. Passive provider chest, storage chest, requester chest. In fact, yeah, give us them all. We'll take every single one. We'll also take the Roboport, logistics robots. We'll take the construction robots. Oh, we're going to need those underground belts as well. Give us a couple more of those. Yeah, that should be fine. What do you guys shoot? Oh, yeah. Forgot. Asteroids. That should give us more than enough to actually upgrade things. Basically, if we just increase the amount of these guys processing, for example, done. That should increase the speed of that quite substantially. And then all we do is upgrade all the splitters. We should probably use the upgrade tool for this, but I think that gets things across nicely. Nice. How about you guys? Yeah, you can actually see it catching up for the first time in a while. There we go. Now, you can see the battery starting to stack up outside. It'll take it a minute, but it'll figure it out. Oh my god, we might have to just get stack inserters for the lot of these. No, they're catching up, you might need an upgrade. Yeah, better. Give it a minute or so, make sure it stabilizes, and then we might have to, actually, I think what we can do is just, extend this on a bit and make a few additions. That way we'll be cramming more throughput through, which gives us more batteries and more everything. Assuming our ability to dispose of it doesn't collapse. That's sort of one of the concerns. And we've now got more ice coming through, which will result in a backup in the system, which means we can probably turn the steam turbines back on. How are we on the power front? Oh, wow. Our power nearly bottomed out. Yeah, I think this little setup down here does pretty good. Ooh, we might want to turn this back on or produce a whole bunch more accumulators. We're going to extend this on even more. What happens if we just keep chucking stuff at the system? Yeah, you should probably go in there. It'll probably be fine. Oh god, that feels like an awful lot. It's I don't know if it's a robust system, but it should be able to handle at least a decent amount of this. We've also got a way to bleed off everything, I believe. So, how are we looking there right now? On one front, we've got 101 science a minute for the last 10 minutes. Actually, we just installed this. This might have been overkill. It'll be grand. We'll see how it works out. Let's just hope nothing backs up in the system. We'll keep an eye on things, but I think we finally have hit our target goal. We did have to bring down some blue transport belt, though. Alright, we added on a butt ton of accumulators, and our power only went below the halfway point. At the same time, we did turn this off, as in we disabled the steam power going to the steam turbine, so that was a turbine-less run, meaning there was no water usage going on, meaning we can now stockpile ice if we want. I mean, I have to wait till that water tank catches back up, but I think we might turn this into emergency power if accumulators run below a certain amount. You know, and then it would make a difference. Just build more accumulators, I think, is what I'm hearing here from the game. Anyway, over here we're also going to get rid of the last of whatever this is. You know what? Yeah, give me that. Why not? To help out with our power demands, what we've done is hooked up a tiny scooch of automation down here. So while there's plenty of power on the grid, this basically turns water into steam and stores it up in this tank. And then once the power dips below... One second, get me over here. Why can't... Once the power dips below 40%, well, then what happens is this liquid pump... Well, it's a pump. Pumps steam, liquids, they're all the same, it seems here. Once it drops below 40%, which it will shortly, this activates the pump. Pump pushes the steam through here, and this activates all these steam turbines. What are they called? Yeah, well, steam turbines. Straight up, there you go. And then that slows the power drain. It doesn't actually have to stop it. It just has to slow it down until the lightning kicks in. Actually, considering how close that was, I think it's already popped back over. You know, I think we'll change that. We're going to change that to 30. There we go. Perfect. That way you won't have to burn through any water to turn into steam. Easy peasy. All right. Now, all of that tweaking, fiddling, cajoling, random wandering, and all that stuff has actually yielded benefits. If we check over here, all of these are maxed out. They're pumping. Like, they're just... There is full resources to draw from here, full resources to draw from here, and if we check under production, we are producing 106 of the electromagnetic science packs per minute. Tiny dip down there. I don't know what happened. What stopped? Damn it. 1 second. Oh. Right. So, the ore. Turns out we've run out. So, was the battery the bottleneck, or was the ore the bottleneck? That's what messing us up. However, we've still got a backlog of the electrolyte, and we've still got a backlog of the solution. However, we're probably going to start running out of the plate short. Actually, no, the plate's made from the solution. You know what? I suppose we will find out. Oh, a little more of a stockpile. We'll see. We might actually just be on that knife's edge where we can produce about 100 stably. That's all we really want to produce right now is 100 stable. I found the bottleneck. It's these freaking gears. Turns out we couldn't get the gears off the line fast enough, so we had to upgrade these to bulk inserters. There was so many gears, it was backing up, and every so often we'd end up with this thing slowing down, which would bring everything to a screeching halt, which would cause the batteries to slow down, and the batteries being the biggest bottleneck, of course, would cause everything to grind to a halt. Just briefly, and then the whole thing would start up again once a little bit of movement happened. And again, yep, we're running out of that holmium ore again. But in all fairness, I don't think this is causing the problems. We have a big stockpile of the liquids it turns into, so it doesn't seem to make a difference. Oh well, let's just give this 1 more minute. And we're still occasionally running out of batteries. No supercapacitors are being produced because the batteries are not getting there fast enough. So batteries are the big bottleneck on this planet at the end of the day. Did not see that coming. Oh well. We're processing as much of this junk as we can. Like, the plan was build what we could and then added the batteries we got, but there weren't enough. So then we expanded the amount of trash we were processing to try and get more batteries. And right now, oh yeah, we've pushed that all the way to the limit. Like, it's only actually emptying out down... Ooh, actually, the left side's a little bit more empty. Yeah, basically they're all filtering through here. We are processing the maximum amount of trash we possibly can. Or are we? No, we definitely are. Well, with a single line, we'd have to double that. I think what you'd need to do is maybe make smaller batches, split them out again. There's all sorts of things you can do, but I figured with 1 line we could get 100 science. Not quite, it seems. Oh well, end of the day, we came out with about high 90s. And battery-wise, yeah, like these 2 lines here, the orange is the pink science, and the blue line up here is the batteries. So we're doing solid, but not quite the 100 we would have liked. But I'm going to call that close enough. But we do have a few things left to do. One, we need a new ship. Another cargo ship like this one. This one's job is to carry science, metallurgic science packs. This one's here's job is to carry agricultural science packs. The Event Horizon is to get us there and back, and this one there is to produce white science. The Event Horizon, we're going to have to fly back to Navis and put together ourselves another ship. The whole point of that ship will be to do a cargo run out here and collect science. Well, actually, first what we're going to do is we got to put down a little rocket silo here. Now, on all the other places, we used to drop down the resources to make the rocket silo, but I don't think we need to do that here. This place has leftover rocket fuel, low-density structure, and processing units. So maybe real quickly here, we could just throw down some of the logistics stuff we sent down earlier. So pretty simple plan here. We're just going to request, or is it give me some logistics robots? We're going to request, well, 100 blue processing units off the network. And I can just grab them from down here. And done? Yeah, perfect. You can chuck them into this thing. Then we just need low-density structure and rocket fuel. 50 low-density structure is fine. For you, we'll just grab rocket fuel. Actually, wait, no. 100 is grand. It takes 100 of this stuff to finish it, doesn't it? And in that case, we will make you 100 as well. Might as well be consistent all across the board. Might take them a minute. Done. No rush in the construction. We will have to get some productivity modules and some speed modules down here, but this will allow us to at least get off the planet and go back and grab ourselves or build ourselves a cargo ship. Cargo ship will come back here and start picking up these electromagnetic science packs and dragging them home. But we're not done here. Problem is, we need to start mass producing these electromagnetic plants. We need to make a ton of electromagnetic plants and start exporting them back to our to Navis as well. And technology-wise, this opens up mech armor, which we have been looking forward to for a while. Personal Roboport Mark IIs. Scrap recycling productivity, but Tesla weapons? Yes. Or Tesla? You know what? Doesn't make a difference. Zappy beam weapons. We'll also get the handheld versions of it, which I think are really good against those giant flame worms. Question, though, is do we megabase... wait, let me try and explain this. Get somewhere slightly quieter. We have multiple planets we can choose to megabase on. Volcanus seems to be the one everyone wants to do. Namely because you have just, well, butt tons of magma and you can turn that into as much basic resources as you want. Fulgoria's... No, well, let me actually... Simpler. Liba, no one wants to come here. Ever. Like, it turns out this place is nightmare fuel for a lot of builders, so definitely a no. Fulgor is pretty good because, well, it's scrap. You basically just recycle stuff and plugging it all in is supposedly very easy. It's just a lot of sushi belting, which would become inefficient, I think, in a giant base. However, there's also the possibility of doing, well, Navis, but importing most of it. Like, I think our plan would be pretty straightforward. Navis has a special unique thing in that it can have these labs on them. Because of those labs, basically you get twice as much out of your science as you put in, which is incredible. And then you get the productivity bonuses on top. It's massive. So putting all our labs on Navis seems like the no-brainer. However, the science production doesn't all have to be here. So we could make, say, the easy sciences like red, green, black, and blue. Those would require an awful lot less resources than just purple or yellow. Purple or yellow would take way more science than, or way more resources than the other four combined, I'd say. I'll have to double check the numbers. And then we would import them from, say, probably Volcanus. Volcanus has, like, it seems to be very good for doing a lot of science production. Agricultural science would be a problem. Electromagnetic science is still going to be a problem. And then we'll have to get Promethium and Cryogenic later on as well. But maybe start off with something small, do like 500 science on each planet maybe to start, and then work our way up to 1,000, or then go up to about 5,000, which means by the time it goes into the labs and comes out, we'll be looking at about 10,000 science per minute. In theory. That's a long way away. For now, though, I think we've got to sort this place out, get the science going back and forth so that we can start researching all the tech under this. And then we'll have to discover Aquilo. Like, should we go out here first? If we go out to Aquilo and colonize that and unlock the tech for this, I think we kind of have to if we want to, well, make the proper super factories. So 100 science here, then 100 science on Aquilo, and then work on the endgame stuff. That seems like the sane plan, so I think that's where we're going to go with it. Sorry about the delay getting this out, but it took me a while to get my brain back into Factorio mode. This hurts. It hurts, but it's fine. It's fine. I think this was a particularly painful way to start back up again because of the way they've organized this. So I think in the end, it kind of works. And as a byproduct, it actually produces its own rockets for us. We don't have to do anything. Kind of nice. Anyway, I'm going to cut this out here. Next up, we'll be doing a transport ship back and forth, automating the production of oodles and oodles of these thingies so that we can send them back home to Navis for a construction spree. And I'm pretty sure there's one other thing we want from her. Ah, yes. Set up a production facility for lots of these accumulators. We're going to need a lot of these accumulators when we come back the next time to do a big build. So I think starting accumulator production now and let it run in the background for, say, 50 or 60 hours might give us enough accumulators to really fill this place out. Anyway, I'm going to cut this out here. I hope you enjoyed it. Good luck.